Okay. Our setup left off right where we were last time. Get that going. That's looking good. And we are in good shape. All right. And better. All right. It's coming along well. I feel like you figuratively can't, because you literally talked. Let's see, literally, figuratively. Where's my analytics? There they go. All right. Well, we'll just let everybody get started. Set. Isn't that the name of that game from that book? What is that? What is that book series called? Tack. No, that's Tack. Tack is a great game. Flat stones, standing stones, capstones. And it's based on a book based on Patrick Rothfuss. Yeah, this is Tack. Tack is a strange game. Doesn't take much to start, just a couple of blocks. But it's like chess, but tinier. And only three kinds of pieces, technically. All right, that's neither here nor there. We were talking about sets. Yeah, sets. All right, just about time to start. Open widget. It's just saying there is no audio. I guess that's because I'm supposed to be talking all the time. All right, so we're going to pick up right where we left off. Last time we had been talking about dictionaries. Okay, dictionaries specifically, we left off with a sorted dictionary. When dealing with dictionaries, they are key-based, so they're very fast to access and find things based on a key. Okay. So today we're going to talk about sets. It's a totally different kind of abstract data type. it keeps track of a set. In the mathematical sense of the word, a set has only unique values inside of it. And we can do very similar operations. We can add elements to a set. We can see if an element exists in a set. We can delete something from the set. But what is unique to sets is the idea of unions and intersections. Okay. Now, how we implement it is not really what we're going today. We're talking about how to use sets. Okay, but if you're unfamiliar with the idea of a union or an intersection, all you need is the standard Venn diagram. Let's open up this here. So let's swap on over to that there, and then that there. Okay. So just as a reminder of what we're talking about with a set, we're talking about the fact that my board isn't plugged in. Let's try that again. Okay. All right. Okay. So everybody should be familiar with a classic Venn diagram. All right. When you take some set A and some set B, the part in the middle is what we call A intersect B. So for the entire board, that would be the set of all sets of the superset, everything. Okay, A is a subset of everything, B is a subset of everything, and then where they coexist, that's the intersection. If instead we have some set A and some set B, and let's just make it interesting here, subset C, the red is what we would call A intersect B. The green or the yellow is what we would call A intersect C. The green, and I know that the circles are in green, but that's the green. That's B intersect C. The symbol for intersect is just upside down U. I suppose I should make sure. Excuse me. And then lastly, let's color it in white. This small shape here is A intersect B intersect C. And we can talk all day about the rules of associativity, commutativity, and so forth. But if we take A intersect B, that's red. If we then intersect that with C, that's the red intersected with the circle C. It's still the same thing. So an intersection is true only if there is something that is in both sets. So the red is in both set A and set B. Contrast that with a union operation. Here's A, here's B. The union A, union B, is not just this part of B. It's not just this part of B. It's not just that part of A. It's everything. So it's anything that A or B touches. Even if A union B, if A and B are not intersecting at all, A union B is still everything in A and everything in B. All right. Okay. So how does that relate to our C# program? Well, if we have a set of elements, we can take the union of those two different sets, and that will create a new set that contains all elements in both. Intersections only if they are in both, you get a smaller set. Okay? So, just like a dictionary, there's actually an interface that defines how a set works. A set of elements of type T, and we can either have a hash set or an ordered set. And again, A hash set is based on usually the hash code or some non-ordering piece of information. Whereas an ordered set, if you enumerate over the items, you'll get them in some predefined order. So a hash set is the C# implementation. It implements a set by using a hash table, which is the same as a dictionary. A hash set is the same as a hash map. So we can do all the same things, and they're constant time. They're fast. Adding an element takes constant time, regardless of how many elements you already have in the list. Removing an element, also fast, because again, it's going to hash the element and then remove it. So the difference is unions and intersects, or intersections. That does take some time. Okay. But we're not talking n squared, big O of n squared, or any sort of polynomial like that. Linear, I think, with the sum of both. So here's how you might start using this. We've got a I set reference. This is specifically so that we can have either the sorted set or the non-sorted set. We should make them all I sets, pointers to I sets. And again, I set is the interface. We can never instantiate an object of type I set. But if we assign a hash set to an I set, that's allowed. And if we assign an ordered set to an I set, that's also allowed. So what we're going to do, we're going to create 3 sets. First set is a bunch of languages, SQL, Java, C#, and PHP. The second set is Oracle, SQL, and MySQL. So those are just a hash set of strings. And the constructor is actually pretty handy. You can give it any iterable sequence. I'm not sure what the picture is about. Any iterable sequence. So since an array is iterable, we can just pass it that array, and it will iterate over those, and each one will be added as its own unique item in the set. The second set, same thing. They're both hash sets, so they are unordered. Okay, the third set actually takes the first set as the constructor argument, which is just going to give you a duplicate. It's going to iterate over every item in the first set and put it into this variable called union. And then union is going to call the instance method union with. Union with takes the second set, unions it with the first set, puts it into union. And then we have a quick little function called print set, takes a I set of type T, and here it is. For each element in set, print it out. That's it. Separated by spaces, okay? So we're also going to do the same thing with a sorted set, but this is, rather than being implemented by a dictionary or a hash, it's implemented using a tree structure, a balanced search tree. So anytime you see tree, you can usually infer that that's going to be some sort of logarithmic based time, because doubling the number of elements in a binary tree is going to just add one level to the tree. If you think about a tree that expands out, each element has 2 sub-elements, and then each of those 2 sub-elements have 2 sub-elements, and then each of those 4 elements has 2 sub-elements. So every time you go down one level, you've doubled the number of arguments, from 1 to 3 to 7. No, 1, 3, 7. Yes, okay, 7, 15, powers of 2 minus 1. Keep on losing my chats. Oh, you guys are being so chatty today. Okay, so here, same thing, but we're going to create 2 sorted sets and then union those. All right. So let's actually go over to the code now. So we do the same thing. Perl, Java, C#, PHP, SQL, Oracle, SQL, MySQL. In the first case, though, they're hash sets, and we display the union and the intersection. Okay, so instead of just doing union, we actually do an intersection as well. So printing the set, this is a method, and it's actually a templated method So it's a template that takes an item of type T. You have to do that in order to get it to work with any kind of ISIN. So here, where it says var, okay, it's really going to be of type T. We could have said T element in set, like that. That would have been allowed too. So here we go. We're going to create the two sets and then display the union and the intersection of the first set and the second set. So if we go back to our open board here. All right. We had a list of languages. The languages that we listed, I'll just draw up on the board here. Perl, Java, C#, SQL, PHP. That was the first set, Perl, Java, C#, SQL, and PHP. So we can think of that as a particular set out of all items. The other item was Oracle, SQL, and MySQL, or SQL, depending on who you're talking to. Now, when you union these, you're looking for things that are the same, which in this case is just SQL. So if you take the when you take the intersection of these two sets is just the set SQL. So that's A intersect B, where this is A and this is B. The union is going to be A union B, Perl, Java, C#, PHP, Oracle, MySQL. And the question is how many times do I put in SQL? Well, the whole point of a set is it must be unique items. So when we say SQL, we're only going to have one copy of SQL. It's not like we lose a copy. Sets can't have non-unique values inside of them. So the union of A and B is Perl, Java, C#, PHP, Oracle, MySQL, and SQL, whereas the intersection is just SQL. Okay, go back to Visual Studio. Nope, that wasn't right. Better. Okay, so as we run through this, let's watch what happens. We'll start right here. Okay, we don't need that just yet. All right, so as we go along, we're going to be doing some printing here. The first thing we do is create the set. It starts out as a reference type, so it's a null by default. And then, let's open that up. The locals window, the autos window, says that we added 1, 2, 3, 4, 5 items. That's because 5 items were added: Perl, Java, C#, SQL. So it's just the debugger telling us that we were able to add things. So one thing you might be able to infer from the constructor is that the constructor calls add, okay, on itself. When we create the second set, we get that. So we have two sets here, which you can't see because this is in the way. Nope, not that. Get back there. Okay. So there they are. We've got a first set. It's got 5 items. In the order, notice the order was the order we added them. Second set, Oracle, SQL, MySQL. So exactly the same. The way that we added them in is the order in which they were iterated on. So now we're going to try and display the union and the intersection of them. So first thing we say is we print the first set. So printing the first set, this is just going to go over each element in the set. The set is the first one. Print out each element. I'm going to go tools, step out of this function. So let me just go over to this command line here. And then move that up like so. Okay. There we go. So the first set, Perl, Java, C#. This is only interesting because of the way that it's going to do it with a sorted set, right? So we printed the first set, printing the second set, we should be able to see that SQL is in both. So when we create a union, it's a two-step process. First, we create a union, which right now is null, okay? And we assign it a starting set of the first set. So now the first set and the union have the same count, 5 of each language. Then we're going to call the union with method. Union with gives us a new value for our union, has 7 things. Now, the first thing had a count of 5, second thing had a count of 3. If you just added them, if they were just a list, you would go from 5 count, 3 count, summing those would give you 8. But because a set removes duplicates, we only have 7, because SQL is only in there once. And when we print the set, you see that SQL is only in there once. But look at the order. The order is the same order that they were added in. So we added first Perl, Java, C#, SQL, and PHP, because that was what the first set was. When we did a union, it then added Oracle, skipped the second SQL, and added MySQL. So for a total of 7 items. Intersection is exactly the same 2 steps. We create a result set called intersect. Intersect gets the first 5. Then we intersect with that second set. So we went from a count of 5 down to a count of 1. It's SQL. Okay, and we print that. There you go, first set, second set, intersection. So any questions on the unsorted, the hash set? Because we had to use the iset reference. Then we had to drop my pen. Okay. All right, so let's get out of here. So that was using hash sets. Hash sets by themselves are a great way of storing things as long as you don't need any ordering to the information. Sometimes you do want some ordering though, and that's where sorted set comes in. Sorted set, in the same way that we had a sorted dictionary, uses some underlying tree structures to make sure that when you add things in, you get things sorted. So what we're going to do is we're going to overwrite first set. So remember, when we did a hash set, it was Perl, Java, C#, SQL, PHP, because that's the order that they were added in. When we run the first set now, it did do 5 adds, okay? But the ordering is based on the ordering values, or the compare to values for strings. Okay. So the order is changed to be alphabetical. C#, Java, Perl, PHP, and SQL. But it's still a set. We can only have unique values. When we create the second set, the second set also now gets an ordering, MOS, MySQL, Oracle, SQL. When we do the union and intersection, we're going to see something a little different now. So printing the sets, there they are. They now have an implied order. Print set just iterates. The set is the one that actually gives us that iterator. So here we go now. When we create our union, it's the same method we just had. We're creating a new union based on the 2 sets. And when we print the set, the union C#, Java, Perl, PHP, SQL, MySQL, Oracle. Is that sorted? Does anybody see a problem with that? So we were using sorted sets. Did we get a sorted result? Yeah, Oracle is the last one. That's definitely not sorted. And the reason is because of the way we actually did the union and the intersection. So we created a hash set. So while we did the creation of those two sets as sorted sets, we didn't do the union as a sorted set. All right. Because we didn't want to, or it's because we created a new value of type hash set. So we can see actually when we do the intersection, it's going to be the same. The intersection doesn't look unsorted because it's only one value. So we have to be careful when doing a function like this where we wanted to just have one function that worked for everything. Now we could have used reflection to sort of decide what type first set was. There is a method called type of, but that actually gives you not something you can declare as. So you would have to use reflection to actually do this a little bit nicer. But the other thing you could have done is overwritten the first set and then work from there. But if you ever use a hash set, you lose all ordering information. If I had changed this, for example, to a sorted set, things would have looked a little differently. So remember, with a hash set, when we did it, we got no ordering information. With a sorted set, we got partial ordering. We know that the first, we know that the first set was ordered when we created it, and the second set was ordered when we created it. But when we did a union, that was the first set, and that was the second set. So let's change this around. Let's use sorted sets in the display routine. Okay. I'm actually just going to let it run straight through here. Whoa. I want to hide that one. Okay, so here I am. Here's the full run of the program using hash sets. So it prints the first set out of order, second set out of order, but the union is fully in order because the union was created as a sorted set. Likewise, when we do a sorted set, everything is ordered. The first set is ordered, the second set is ordered, the union and the intersection are sorted. All right. Close this down. All right, so those are sets. Why is this still running? So you can use a base interface pointer to point to any type of set, sorted or interface. So this is actually the end of where we were trying to get to last class on Friday. Dictionaries, they map a key to a value, and we've seen how those can be used when we talked about the adventure game. The hash table, okay, is one way of implementing a dictionary, and it maps keys to values through some sort of a hash function. It's fast for finding and deleting things. When you want to do a sorted dictionary, it uses some sort of balanced tree or just tree structure. Whereas a set holds groups of unique elements, and you can't have duplicates. In a hash table, you could have duplicates. Okay. Sorry, I should say you can have duplicate values, but not duplicate keys. All right. So before we move on there, any questions? Okay, so we're going to move into another chapter of the book now. And this is sort of advice from me to you on ways to make your code easier to deal with. It's called high quality programming code construction, high quality practices that you can use to make your code easier to debug, easier to maintain, and easier for other people to maintain after you. Okay, so these are suggestions. Okay, every company that you go work for, if you're going to be writing code, is going to have their own conventions. Okay, for their desired way of looking at things. If you've ever taken a course with me before, you know that I hate squiggly brackets on the same line as an if statement or a for statement. It's just my convention is the squiggly bracket takes up its own line. People who do Java a lot, they don't do it that way. They always put the squiggly bracket. So it's conventions that are based on the language you're using and the group that you're coding with. So based on how well you adhere to these guidelines, that describes your code quality. It doesn't tell you whether or not the code works. It tells you how it looks, okay? So these are, in some ways, cosmetic. So things like naming your identifiers. How do you name a variable? Do you use camel case, which is every other word gets a capital letter? Do you use underscores? Do you name classes differently from interfaces, differently from properties? What are your rules? Okay, how do you format your code? These are what we're talking about. Okay, and then there's actually like how can you organize your code with abstraction, data encapsulation, multiple levels of inheritance when you need to create a class. Those actually have a little bit more real effect on the maintainability of your code. Okay, so what is high quality programming code? Well, let's start with code quality, okay? Take a look at this line. First person to fully describe what this code does gets an extra 2 points if you can do it in the next minute. Yeah, no takers. Okay. This is rough for several reasons. Let's start with a simple question. There's a variable there called I. It has a value of 5. What is the value of the variable called value? Put it in the chat, quick. What's the value? It's an integer. What is its integer value? Nope. It is not 10. Does anyone know why it is not 10? All right. You're starting to think in the right frame. You said 2. Maybe it's a binary 2, but it's not. In many languages, if you preface a number with 0, that actually implies octal. That's a throwback to a lot of older languages. So that's an octal 10. Nope, it's not hex. OX is the preface for hex. This is octal. Therefore, 10 in octal is the value 8. So value is 8. So right there, that's a bit misleading. It looks like 10, but there's no comment or anything saying, hey, by the way, this is octal for reasons that will be obvious if you read my code a little more. So right away, most of you would have assumed that there would have been a switch case for 10, and I'm looking for it. Ah, there it is, case 10. W equals 5, console, right line, W, break. All right, so if I asked you what did this do, it probably would have said it prints 5. But it doesn't, because value is an 8. So we got to go to line 8, which prints 8 and then breaks, which certainly sounds a lot like, no idea what that's about. Yeah, the second thing about the code quality, not just that it's misleading in its variables, but it's not well structured in terms of how many lines it's spaced. It's got tabs in random places. Okay, this is code that if you handed to me, I would not even bother trying to. Yeah, it's horrible to look at. That's exactly right. It's horrible to look at. Yeah, it makes your eyes bleed. Trying to logically decide what's going on is very difficult. Okay, same code. It's better formatted. So now at least you know that there's a case for 10, 9, 8, and then every other option, which prints out the line k minus. What is k minus the character f? What does that even do? You're taking an integer and subtracting a character? Is that going to look at the ASCII value of an f, which is, since it's a lowercase f, that's going to be 61, 62, 63, 64, 65. 65 hex. And then k goes from 0 to I. It's not immediately apparent what this code is supposed to do. Even with perfect formatting, the way I like it, right? The squigglies are on their own lines. It's unclear. So when we talk about quality, we're actually going to talk about two different kinds of code quality. This, by the way, is terrible quality. This is better, but still bad. Okay, so the external quality is what most of you think when you talk about, is the code good? Does it behave correctly? Does it make the results correctly? Does it run fast? Is it easy to use? That's external quality. That's not what the internal engineers have to worry about. They have to worry about internal quality. Okay, is it easy to read, understand? Is it easy to expand, add features to it? Is it easy to modify, fix bugs? If you fix something in one part of the code, does it break something somewhere else? We talked about cohesion, code cohesion, and coupling. This is part of internal code quality. So if you've got high quality programming code, when we're talking about internal quality, it's easy to read, it's easy to understand, and it's easy to read and understand in chunks. Okay, you don't have to keep the entire program in your brain in order to understand one function. All right. So if it's high quality code, it should be well tested. So when I've been giving you assignments, I've been providing the tests. If they pass all the tests, it's guaranteed to have good external quality because I wrote the tests, and that's how your grade is based on. So it's, you get all the tests right, you get full credit, therefore it's got good external quality. Okay. Is it well architectured? Design, is the classes and the abstractions appropriate to the problem you're solving? Then is it well documented? You will, if you search for self-documenting code, you will find two different camps. Camp number one, self-documenting code is the only way to write code. It doesn't really require that many comments. You just write it in a way that's easy to understand, and everyone will be able to modify it. The second camp, there is no such thing as self-documenting code. Yeah, I'm a little bit more the first camp than the second camp. And I will, I'll have a spirited discussion with anyone who wants to discuss that otherwise. But there are ways that you can make your code more self-documenting, even if it is not fully self-documenting. Okay, so let's continue. So I talked about your conventions. You have to pick a code convention. Which code convention is up to you. There are plenty out there. In Python, the language Python comes with its own set of coding conventions that's part of the language. It's called PEP8, P-E-P, I don't remember what PEP8 stands for, but it's the conventions that everybody is supposed to use. They tell you what kind of white space you should use, what kind of indentation, how to name things. Pascal case is every word gets a capital letter. Camel case is the first word is lower case, and then every other word after that is capital. Whether you use prefixes, like in the early days of Windows, there were all sorts of prefixes that you could put in to explain what kind of an object it was supposed to be. It was encoded into the name. It also includes things like best practices, how you should make classes, what things you should provide in a class, what things should go in interfaces. Okay, so these best practices. So we talk about coding conventions. These can be industry defined, PEP8, or they can be privately defined by the company you're working for. What's important is that you read them, follow them, understand them, and use them. Okay? So for C#, well, actually for all the .NET languages, there is a design guideline. You can go to it's actually docs.microsoft.com now, not MSDN, but maybe that link will still get you there. Design guidelines for developing class libraries. If you're going to write a class, you follow that, okay? If you're in an organization, they have their own conventions. Generally, they will lint their conventions in their IDE. Okay, linting is the process of making sure your code looks nice or looks correct. So when you're working on a large project, one of the first things at the start of a project is to define your coding conventions. And you'll have big meetings about this. This is a real thing, that you have meetings about whether or not the squiggly bracket should go on the same line as the for loop or on its own line after the for loop. It doesn't really matter. The code's going to run the same, but the convention has to be there so that it's followed. Okay. So typically you'll start with a base set like the Microsoft recommendations and then extend them. You'll add things to them. Okay, you'll get more restrictive, not less restrictive. But it's not just code conventions. It's how do you think about the problem, okay? If you can put your mind into the right frame of reference, everybody in the project puts their mind in the same frame of reference, it's going to be easier to do things like make sure that your code is well architected, managing the complexity of that. In the demonstration for the adventure game, we managed complexity early on by defining data structures in such a way that very little code had to be written to implement basic game functionality, right? We created a list of rooms. The rooms knew how to get from the room that you're in to some other room. Okay, we knew about vocabulary. So really the only game engine we wrote was the parser, which just took the words and tried to use them. And then we started implementing special purpose words, of which there were, I don't know, 30. Okay, so that architecture, if you have a good architecture, you can reduce your task in size. Okay, so defining good classes and methods and the way you name things. Okay. People often, they glaze over this, and it's good to be reminded every once in a while. If you're the key to being an effective programmer, maximizing the portion of a program that you can safely ignore while working on any one section of code. The smaller you can make a block of code, obviously that's good from a standpoint of memory consumption. But the smaller you can make it and ignore everything else, the easier it is to do, okay? Working in a classroom setting, you get small projects, and those projects have small solutions. If you can reduce a large project, millions of lines of code, down to a bunch of small projects that are 100 or 200 lines of code, you're going to be a lot better off. If you can define a problem in terms of one small testable piece, okay? That's key. If your small piece of code relies on lots of other little pieces of code in order to function, it's difficult to make a change to that piece of code. So, external code quality, correct behavior, it conforms to the requirements. You have input requirements and output requirements. You conform to those. The program works and gives correct output. It's stable, doesn't hang, doesn't crash. If in 90% of the time it gives the correct output, but in 10% of the time it crashes and dies, that's not good quality for obvious reasons. It shouldn't crash. It's better, and you'll spend a lot more time on that last 10% of weird edge cases that hang. But catching all of those, in the days before exceptions, that was actually quite difficult because you had to test for every possible thing that could ever occur and have some sort of a case for them. With exceptions, you can just say, if something weird happens, throw up an error message and restart to some known state, okay? And then again, it goes back to reducing the amount of the code base that you can ignore. Okay, if you know going into a particular function that you're in some stable state, as long as you ensure that when you leave the function, whether it be through exceptions or through normal means, that it's also stable. So you can ensure that it's stable going in, stable going out. Even if something bad happens in the middle, you recover from it right there. Okay. And I've been pushing that all semester long, right? What's my favorite integer? In the chat. My favorite integer is testing the correct response to incorrect usage. So external code behavior is just, external code quality is just the correct behavior. But I haven't really been testing you on, is it easy to read, easy to understand? That test is going to come in your group project because you're working with other people. And other people in your group are going to be a lot angrier at your crappy, or I shouldn't say crappy code, your crappy variable names. You call everything temp. Well, that's not easy to read. It's not easy to understand. It was for you when you wrote it, but you're going to find the person who's most angry at your bad variable names is you, because you're going to come back to your code after a week or two and you're going to try to make a change. And you're going to realize that you have no memory of writing this code. You don't remember why it worked. And actually, that, like, can I have a little anecdotal story for you today? Little anecdote here. There's my, I want to go over here. I want to go to this and go over here. Here is a GitHub project that we use it as part of the department. It's called Snipe It. It's for asset tracking, okay? Where is it? So this came out this week, their digest. And this, nope, commits. Here is a commit somebody made. So this is a GitHub thing. And you can see it's a pretty fairly straightforward commit. It's only one change, 5 lines. He deleted this thing that said, if the default location is set and the default location, sorry, if the request has a location and the location that we currently have doesn't exist, overwrite location ID with the target location. Okay, fine. If it's in the request and it doesn't exist, overwrite it. But over on the right, wait, why are we doing this? This overrides the stuff we set further up in the code. Follow up here. WTF, commented this out for now. I don't know what that acronym stands for, but we can assume. And I looked at this because I do follow along with this code. I said, this looks awfully frickin' familiar. I remember this. Why do I remember this? And it's because, this, by the way, was this commit. Where's the date on this commit? 4 days ago. So that was the 9th, April 9th, 2020. I went and I looked. I did a little bit of looking. I filed a bug report on this line of code on January 8th, 2019. Not only did I file a bug report, which was a well-filled out bug report, I tracked to that line of code and I put a pull request in for a fix, okay, based on what we're doing. And in my implementation of this server that we run to keep track of assets, there is still a manual change for that line of code. So when I talk about maintainability, GitHub, I don't have it in the slides, but GitHub is a invaluable resource because not only does it let me know that, hey, I really did do something about this many, many friggin' moons ago, but I can actually look and see who wrote this line and when, using something called git blame. Excuse me. I'm getting a little overexcited. So, if you look, these lines, this, by the way, is PHP, with a hint of Laravel and a few other things. If the request has a purchase date, if the request says who it's assigned to, if the request knows where the supplier came from, just set that. If the request has a default or a return to location, set the return to location. This has a separate line here. Okay, line 504. It was done in a separate commit. And notice what he says. If the location has RTD location ID, set location ID equal to RTD location ID. Now, I have a theory as to what happened here. And the theory is copy and paste. He needed to add location to the checkout API, not the default location. So he grabbed this, he copied it, he pasted it, and he changed RTD location ID to location ID. Done. And he didn't change this or that. It's as simple as that. Okay. But the ability to track things through git blame is pretty invaluable. So this is actually a pretty cool piece of software, open source and everything. But that was something that popped up on my radar today. And this idea of being able to maintain it was, is in line with today's lecture. Okay. All right. Let's continue on here. All right. So how do we name things? So this is advice for you and your project. How do we name things? Well, an interesting note. Remember, the guys who wrote the book, Bulgarian. Always use English. For whatever reason, this is what the industry has settled on. Okay. If you're going to work in code, apparently you have to work in English. This is not me saying this. I am a native English speaker. These are people who were from Bulgaria. And as you see in a lot of their comments, many comments and strings, not English. But this is what they're telling you. So that gives you an idea. Avoid abbreviations. This is something that a lot of old coders do. Okay, older coders. Because it used to be that you had to have an 80-character limit per line. And so you wanted everything to fit on one line. So you made concessions. You did a trade-off. You said script count instead of scripts count. It's really not necessary anymore. Okay? If you are not a touch typist, this is going to be more difficult for you. I encourage you to grab any typing tutor. Maven teaches typing. Mario teaches typing. They exist. Okay? But don't let laziness of your fingers give you a difficult to understand variable name. Another one, this Ditbugredjikperton. What the hell is that? A date-time Bulgarian regular expression pattern. Well, that actually is a lot easier to understand. Apparently, there's a regular expression pattern that extracts out a date and time from a Bulgarian idea of date and time. So you may have seen some people do month, day, year. It's typically how we write almost everything, month, day, year, in common parlance. But I put almost all of my file names as year, month, date, because it makes it sort better. I don't know how they do it in Bulgaria, but that regular expression pattern would tell me. These three questions should always be asked whenever you're making a variable name or a class name. What does this thing do? What is the intent? Okay. What is it used for, depending on what type of item you're making? Okay. Good example names. Factorial calculator. What does it do? It calculates factorials. Students count. It counts students. Math.py obviously is about baking. Config file name. It's the file name for the configuration file. Create report. You know what it does? It makes waffles. Whereas something like K or junk or button 1 or something doesn't really do anything. Now temp and temp var, I'll fight for you on that one, okay? Sometimes you just need a temporary variable. If you're doing a swap, you can swap two items through a temporary variable. Okay, fine. But if you're going to use it on something, and again, you're your conventions are going to iterate. Can you elaborate on your video YouTube name? Yeah, I thought my YouTube naming scheme was pretty clear. Not that I'm consistent with it, but that's a different problem. Oh, wait, hold on, though. You just distracted me. Temp swap. Oh, your conventions are going to say this type of thing, but if you're going to use a variable for more than, say, 5 lines, it should have a real name. If you're using like a one-off and you just kind of throw it in there and you get rid of it almost immediately, sure, you can call it temp. I don't think that we're ever going to get away from using I as an integer. And do you know why we use I as an integer for loops? Because in Fortran, integer types were I, J, and K. And then floating points were M, N, and further on there. And that people just got into the habit of using I as an integer. So think about it. Fortran, like Fortran 77, yeah, 1977. We're still using I 50 years later. So be careful when you start picking variables because they can stick for an unintendedly long time. All right. So sometimes you can make things that look general and not descriptive, but they mean more based on their context. So a method called generate all by itself doesn't really explain generation. Okay, but if it's inside the class labyrinth generator, okay, now a generate method is probably going to generate a labyrinth generator. All right, we're actually out of time. So the question was, can I elaborate on my YouTube video naming scheme? I usually will, when I'm doing like recordings, it records with year, month, day, hour, minute, second. So that's the name of the video. When I upload it, I don't want to have to do a whole lot of editing, so I put that at the end, and I just put the general lecture title at the beginning. So it doesn't sort well, but it allows you to look at the date that it happened on, but also give you the more relevant information first. Okay. So we'll pick up on this. We'll spend the next few times. On Friday, I'm going to put out some sort of a survey to do demos for the final project, meaning what time slot do you want to sign up for? We are going to have to use Zoom, so we'll be doing Zoom meetings, and I will host the Zoom meeting, and then I will allow the group leader to take control. On that note, Group 11, you exist now. I've heard back from you, but Group 9, I have not heard back from you. If you have not elected a group leader, or if you're a group leader who's been elected but not told the TA, you're in trouble. So please do that as quickly as possible. All right, that's about it for today. Any other questions? All right. I will see you on Wednesday.